Okay guys, so in this video, I'm going to be explaining involuntary movements, which are also known as reflexes. Okay, so the first thing I'm going to do is I'm going to ask you to imagine a scenario. Okay, imagine you are cooking noodles, right? And when you're cooking noodles, you turn on the stove and then you put a pot of boiling water on to boil your noodles in. When you put your hand over the boiling pot of water to see, oh, is it hot enough for the water to come? You're trying to feel for the how hot the steam is, right? You suddenly feel a burst of heat. What would your immediate reaction be? It would be to take your hand away, right? So this is what we call reflexes. So the reflexes are basically a response or something that we don't think about in response to a painful stimulus, most usually a painful stimulus, or just like any stimulus in general, as we'll see with the flexion withdrawal reflex. Okay, or the myotac reflex, my bad. So basically, let's talk about what the general definition of the reflexes. So obviously, as I stated, it's just an involuntary response. I don't know why I put in there. Sorry, guys. It's just an involuntary response to a stimulus. And so what happens is reflexes don't actually reach the brain. That's what allows for such quick reaction time. Because think about it, when the usual response to a stimulus is that, oh, the information will travel up from your spinal cord to your thalamus, then to the right side of the right portion of your brain, and then your brain coordinates the movement, so on and so forth. But actually, in spinal cords, none of that happens. Your brain, your stimulus will reach the spinal cord, and your spinal cord will do all the processing and will initiate a movement upwards. So before we talk about the spinal cord, right? Before we talk about volunteer and involuntary reflexes, first thing we've got to understand is the differences in general anatomy of the spinal cord. So, okay, first what we're going to look at is this is, I believe, a thoracic spinal cord, if I'm not wrong. Basically, your thoracic is towards the lower half of your body. I may be wrong, it might be the sacral region as well, but we'll see. I'll put it in the description, the right portion. So basically in your spinal cord, there are 5 regions. So there's your cervical region, thoracic region. Yeah, it's not spelled with an S, I know that. Your thoracic in your lumbar region. Oh, that's what I was missing. This might actually be a lumbar spinal section, but you know what? We'll figure it out. And your sacral. Actually, there's another portion called your coccyx, which is also known as your tailbone, right? But we don't really consider that part of your spinal cord. It's more of your tailbones. So for the purpose of this video, we're not going to include the coccyx. So we only have 4 regions of the spinal cord. So these are from your top to bottom. Your cervical is most closely associated with your neck, and your sacral is near your hips. So basically, how it works is that let's go over the general anatomy first. I always associate red with ventral or forward, which are these small regions. So your ventral horns is what they're called. These little protrusions to the front, they're called the ventral horn. And these are actually associated with movement. They send out information regarding your movement. 1 second. Here we go, guys. So the ventral horn, basically what it does is it sends out motor information. And now I associate blue with posterior or dorsal horn. So these large chunky ones are your dorsal horns. Dorsal horn. So your dorsal horn receives sensory information, right? So basically, it will receive the information. And basically, just a really kind of fun fact actually, this part, this inner part is actually the white matter And the outer part is the gray matter. So this part that looks actually white is your gray matter, I believe. Let me just double check that. Maybe I might be wrong. Gray matter versus white matter. Spinal cord. Because I remember it being flipped. Yeah. Oh wait, no, I was wrong. Ignore what I just said. Sorry. So this stuff is called your white matter because it's white, and the inner portion is the gray matter, right? So this piece is the gray matter, gray. And this is where all the processing happens, and the white matter is all the exiting stuff, right? So which makes sense, obviously. I don't know why I said it was split, but okay. So this is the information. So this is the general anatomy of the spinal cord. I'm pretty sure you need to know this and this, just to gain an understanding for the brain beat. And I didn't even get asked this question until like nationals, right? So you don't really need to know this for regionals. But yeah, this is pretty helpful information. And basically, why I was explaining this is because it's important to know the anatomy to understand reflexes. So let's go over reflexes now. I hope you guys got that down, so that we can just start. Yeah, I'm gonna erase it now. Sorry, guys. Okay, all right. So now what we're gonna do is we're gonna start off by tracing the path, right? So what we're gonna do is basically what happens is we're gonna go over the myotactic reflex as just an example to understand how it works. So your nerves don't actually go straight to your brain. They go in to your spinal cord, right? So let's just say that at the doctor's office, you're hit with this mallet thing, right? So when you're hit with that mallet thing, your nerve fibers in your knee will detect a small like contraction, right? Because in these leg muscles, it'll basically um, cause a little contraction in your extensor muscle here. So what it'll do is when they tap it, your muscles will kind of clench in reaction to that. So your extensor muscle will cause a small kind of jerk outwards. And the reason for that is because your neuron, this purple thing is a symbol for a neuron, right? So your neuron will come in to your dorsal horn over here, and it will say, okay, there's a little, I felt a clench there. So what you're, or I felt a stimulus here. It didn't feel a clench, it felt a stimulus. It felt a tap. So what then your neuron will do is it'll process the information, and using an interneuron, which is basically a neuron with no distinctive function, it's just a connect, it will tell the efferent neuron, which is your motor neuron, to create a small clench in your extensor muscle, and to tell the blower muscle, which is your flexor muscle, to relax. It tells it, calm down, just don't do anything. And so that way, your leg will move out, and your leg will just allow it to move out, right? So that was kind of a confusing reaction. I'm sorry about that. But I do think it will make a little bit more sense with flexion withdrawal reflex. Okay, so first, let's say that there's a really sharp pin here, and the person is like not looking at the ground, and then they get pierced, their foot gets pierced, right? So when it gets pierced, your sensory neuron, which is the neuron that's associated with sensing, it's like a receptor. So your skin receptors, your pain receptors, or your nociceptors will be activated, and it will go to the spinal cord, and what it'll do is it'll go to the dorsal horn, right? Because that's where you receive sensory information. And then there's communication happening between all of these neurons. So what will happen is that your immediate reaction is to pick up your foot from that position, right? You want to get away from it. So that means that your foot has to flex inwards. Your knee has to flex. So your flexor muscle will be activated, which is what your neuron here will do. Your motor neuron will do. It'll cause a flex here, but at the same time, in order for one muscle to flex, the other muscle has to relax. So it'll tell the extensor muscle here to calm down, to just relax so that your muscle will flex.
At the same time, though, your other foot has to stabilize you. It has to make you go straight, right? So the neurons associated with the other side will also activate, the motor neurons will also activate, telling your muscles here to your flexor muscles here. I'm sorry. Okay, it'll tell your flexor muscles over here to to relax because you don't want it to bend. You want to stabilize yourself. You want it to be as firm as possible, like a pillar. So you want it to extend, right? So it'll tell your extensor muscles to activate, to stabilize your other foot while picking up your other one. So this is called your flexion withdrawal reflex. I like to think of it as a pin reaction, right? Whenever you have a pin, you want to just flick your foot off. But and this is flexion withdrawal reflexes also when you're putting your hand over the hot stove, you immediately flex backwards. You try to remove your hand immediately. That's flexion withdrawal, right? Because you're flexing your hand, trying to take it away, and you're withdrawing from the hot stimulus. So I think of it like the pin stove reflex. Then this is basically used at the doctor's office. I like to think of it the rubber reflex because you use a rubber hammer to check. And I also like to call it like the gymnastics one. Okay, and let me tell you why. Gymnastics. As you can tell, spelling is not my strong suit. Basically, when you flip, right, your body has to kind of meet contact and it needs to stabilize you, right? So as your foot is sensing that you're about to land, it's going to have to stabilize. Your knee has to jerk out to stabilize yourself. So that's why you have your gymnastics reflex. And another thing I just like to go over is a little bit of anatomy in this, right? So let's move on to the next slide. Um, So what I'd like to go over is muscle spindles. Okay, so do you remember when we were talking about how muscles flex and extend, right? So let's take the myotactic reflex, so that's your knee-jerk reaction, as an example. When your knee flexes outwards, right? So let's just say this is somebody's leg. I hope no one's leg looks like this, because yeah, this is the knee, guys, just in case. Oh my God, this does not look like a leg. Sorry, guys. Here, let's say this is the foot, right? And this is the knee. So when it extends outward, how does your body know how far it's stretching and how far to stretch it? So there are actually small receptors in your tendon. So again, your tendon is the don't confuse it with ligament. A ligament is a piece of connective tissue which joins a bone to a bone. A tendon is something that joins a muscle to a bone, right? So it detects the change in a muscle, right? The muscle spindles are in your tendon, which detect how far it's stretching and how much it's stretching, right? So this information from the muscle spindles comes to the Golgi tendons. So Golgi tendon organs, which are another form of neurons found in tendons. And what this does is it basically um, this information tells the Golgi organ how much more pressure to put or how much more to extend it or how much more to flex it so that your knee doesn't extend too much or too less. So the reason why doctors do this test is to make sure that your body is well calibrated, right? And to make sure that your reactions are happening in time and also just to make sure that no all of your organs and all of your sensory information is kind of synced with each other. So let's go back to our example, right? The Golgi tendon organ tells you, okay, you need to stretch a little bit more farther, or you need to stretch a little bit less, or you need to flex a little bit more or flex a little bit less, right? And your muscle spindle tells you, okay, this is how much is happening, this is how much is doing, right? But okay, what happens when the movement is over? Well, the muscle spindle it can't reset unless it has a stimulus, right? So that's where gamma motor neurons come in. So not to be confused with alpha motor neurons, gamma motor neurons reset muscle spindles. It says, okay, the movement is over, the muscles are returned back to their original position, right? So it keeps them taut and it keeps them the most accurate, right? So alpha motor neurons are what initiate the movement. Gamma motor neurons are what keeps them tight together, which is what basically controls and regulates how. Okay, to put it in a broader sense, actually, the gamma motor neurons are what's majorly responsible for calibrating the motor system. Alpha starts it, but gamma calibrates it. It makes it more synced and it makes it more accurate and more precise. So gamma motor neurons were actually the hardest for me. I kind of like even after I competed and all of that, I it's still giving me a hard time. I had to watch a few videos before I could explain this to myself. So I will link a few videos that I found very helpful for these three. And yeah, as usual, if you have any questions, please email me or comment down below. And I hope this video was helpful. Thank you.